Okay, welcome back. I lied. This is the final video in the Shaders 101 series. I decided to break it off because there's definitely enough to talk about on this topic to warrant a full video. And what we're going to do is we're going to build a feedback system and use that as an opportunity to look at working with multiple buffers and talk about image effects and how they work. So basically in this shader, I have a very simple main image loop, which just samples the output of buff B here. And what buff A and buff B represent are two steps in an image processing chain. In buff A, we're applying a blur, and in buff B, we're applying a sharpen operation, and then we pass that back to buff A. And so it just continues to do this operation in feedback, and in our image function, we're just sampling from the buff B portion of that process. And that looks like this, which isn't particularly exciting, but we'll spice it up a little bit. So how do we write a blur? So if you Google image kernels, the first thing that comes up is this really excellent resource, Image Kernels Visually Explained. And it allows you to kind of pick through some different image kernels, look at the results, and look at the values that determine them. So the way that we write or define an image effect is we define a convolution kernel. And this is basically an array of values to multiply against the neighboring values of a pixel. So in this blur kernel, we're really looking at this pixel, 0.25. But we need to multiply our neighboring pixels against these corresponding values, and then ourself against 0.25, and then we add up all of these numbers, all of these results from these calculations, and the sum of that operation is our final pixel value. I think I explained that well enough. So the way that we do that in a shader, and I've made this little grid to help visualize it, is we're going to need to move around our current pixel. But because we're working texture coordinates, it's not going to be enough to say, okay, I want my current position -1 on the x and then -1 on the y, and that will give me my neighboring pixel here. Because we need to move in fractions of 0 to 1. So the first thing that we need to do is get our texel size, which a texel is kind of like a pixel in texture coordinates. It's the size of one pixel to the left or right or whatever. So we get that by taking 1.0 and dividing it by our iResolution.xy. And that will give us the correct value regardless of our aspect ratio. And so now I define an array of vec2s, which are our offset locations from our center pixel. So the first one is one texel to the left and one texel in the up direction. So it's negative texel x, negative texel y, and that gives us this pixel. And then the next one is 0 on the x and negative on the y. So we are here, right? We stay here on the x and we jump up here and grab that next one. And so I'm just defining all of these locations, including my location is offset 4 at 0, 0, so the center pixel. And then I define my blur kernel. And this is the exact kernel here. I've just borrowed these values. And I'm defining a float array with 9 positions. And I've laid it out like this so we can actually visualize the kernel. So I store all these values. And then I set up a vec4 that's going to hold my the final pixel value I get from the sum of these operations. And I iterate over, from 0 to 9, and I add to that sum the sampled texture minus my kernel. Multiplied by my kernel value. And then I'm basically just going to set my final value to that sum. But there's a little extra code here to account for the fact that at the beginning of this feedback loop, I have to sample from something. I can't just sample, like say, okay, blur this, and there's nothing there, right? So I'm going to blur the London image first, and then after 10 frames, I'm going to swap over to outputting the sum of my kernel operations. And then in buff B, we have virtually the same code, but the kernel is different. In this example, I'm using a sharpen kernel, which looks like this. And this kind of looks for edges and enhances edges in an image. So you can see I'm sampling from iChannel 0, which is represented by buff A. Oh, and I never said this, but each buffer, right, including image, each one of these tabs, they can have independent setups for iChannel 0 to 3. So if I click over to buff B, I have buff A on iChannel 0 and buff B on iChannel 1, but in buff A, I have my London image in the iChannel 0 slot. Anyway, so buff A samples from the output of buff B, whereas buff B samples from the output of buff A. And so they're just ping-ponging these buffers back and forth. And in my final output, I sample the sharpen stage of that process. And I didn't address this, but I'm saying for the London thing, if we're looking at London or if we're looking at feedback, I say if iframe is less than or equal to 10, or if iMouse.z is greater than 0. And that just means if I haven't received a mouse click. Or rather, if I have received a mouse click, sorry. Okay, so that's feedback. So let's just spice it up for fun. So I'm going to do some zooming on here. So I'm going to I want to scale my coordinate system. And the way I'm going to do that is do my classic st. Oh, and I never addressed this either, but st is an interchangeable representation of the coordinate that you're currently at. So you can say uv, you could say st or xy. They're all conceptually the same thing. st plus equals vec2, or rather minus, but whoa, I didn't know I could do that. Oh, wow, look at that. I didn't know I could do that either. You can hold command and use the arrow keys to tab through the buffers. And I'm going to do a scaling operation here, so I'm going to multiply that by some mat2 that I don't have memorized. And then I'm going to add back 0.5. Actually, I think I do. It's mat2 that looks like this. 0.99, 0, 0, 0.99. Yeah, look at that. Okay, so that's the scale, mat2. So now I got this zoom thing. Oh, let's do one more thing. I'm going to go back to the book of shaders and borrow the rotate 2D mat2. I'll never remember that. I'll pop it up here. And instead of rotating via time to get this kind of uniform rotation, I'm gonna multiply by something that I pull out of what I'm sampling during this process. So the texture that I'm pulling in, I'm going to use some feature of that texture to determine my rotation. So it will be independent per pixel, basically. And what I'm going to do is I'm actually up here, before I do anything, I'm going to make a vec4 called text and just pull that in. So that's going to be equal to texture. I'm going to sample it iChannel 2, which is the output of my sharpen, and plug st in there. And then I'm gonna multiply by rotate 2D, but my angle that I'm going to plug in is going to be equal to the, let's say, the red channel of my texture. And I'm sure that's just going to be way too crazy. Like, it's just going to freak out. So let's just scale that down, because every step that we do this, because it's in feedback, very small values matter a lot. They compound very quickly over time. So I'm going to scale this down a lot, even more than that. And now instead of having like a uniform rotation across the canvas, I have something which is like more nuanced, and it's determined by the characteristics of this image.